Hi there. This is Raj Aware from Group 1, and I have Josh Kane and Nathan Coyle with me. And today we are going to present our final project, which is the water and the environment sensor systems. Getting along with the abstract, this project will be an environment and a water sensor to make use of large number of peripherals and to collect more readings to display. We would also like to find a way to implement or capture pH readings of water with a pH meter. Our system goal is to let users collect and trust their own environmental data readings, temperature, humidity, and water levels. In short, the purpose of this project is to have various environmental sensors and a pH sensor, and we also want to create an embedded system that has many different environmental sensors and a controller to cycle the display to the different types of measurements. The completed system allows users to see how many accurate environmental data is collected. With the continuing CO2 emissions from more than technologically advanced society that all the users large amounts of fossil fuels damaging our ozone layer, and that's why we are targeting to make an environment sensor. These facts show that it is imperative to be able to collect data and research in this field. Some of our objectives are to start like physical system construction. We also have to build a MP lab project code. One of our main objective is to log our project work in a Gantt chart. We also have to calculate our cost for the final project. And one of the last main objectives is to start testing our system, our sensors, and start taking measurements and documenting the data.
So for the methodology section of this final project, I have two pictures here. The picture to the right shows the various components that we will need to hardwire our circuit, and the picture to the left shows the wiring of all these various components. So stating the problem for this project was to create an environmental sensor to collect various environmental readings by hooking up various sensors to our microcontroller and then displaying these on the LCD. We needed an embedded system in order to do this. The sensors we're using were the ultrasonic sensor, the water level sensor, and the 3-pin DHT, which essentially is used to measure humidity and temperature. We're also used a motion sensor for this. For these sensors, we had to take analog data and convert this to digital. We also used a membrane keypad to cycle through the various sensors we wanted to use. The membrane keypad is connected with 8 different pins for the 4 respective rows and columns, and then we needed an LCD to display the data. Here is a picture for the Proteus simulation. This particular picture has the ultrasonic sensor hooked up and the DHT sensor hooked up. This is a diagram for how we wanted to create this project. So we've got the PIC microcontroller, the PIC16F886, and it's connected to a motion sensor, and that sensor connects to ground and positive and has a pin for the data. It also has ways to adjust the sensitivity of it and the time delay. Then we had a water sensor with a passive buzzer, and the water sensor also has a ground and a positive pin, and then it has a pin that takes in the data. When it is submerged, the passive buzzer will go off. Then we have a 3-pin DHT connected to this. This reads in the analog data and converts it from analog to digital. This uses the ADC module that we learned in Lab 3 to convert from analog to digital for a reading, and that has a ground, positive, and data pin. We also had an ultrasonic sensor, which uses 4 pins. One is positive, one's a ground, and then one is the trigger and one is the echo. we set the timer register when the trigger pin is pulled, and then when it bounces off of something and comes back to the echo pin and the echo pin is raised high, that timer is stopped. And using the time data from that, we are able to calculate the distance and send that to the LCD. We had an LCD which was connected respectively to the PIC microcontroller with pins RB0 through RB7 connected to D0 through D7. And this was used to display the various results on the screen. Then we also have a membrane keypad, which is used to cycle through the sensors. This has 8 pins, 4 connected to the rows and 4 connected to the columns. And depending on the button that is pushed, it'll trigger various signals, which will then be sent to the microcontroller to pick the sensor that is to be used. For system modeling and algorithms, we compile code and link to peripheral base code in a separate Word document. The tools for our project objective were a complete system to take readings, an external pH meter, a phone to collect the data, a cup for water, and pH up and down solution.
So to discuss our results, we actually didn't meet all of our objectives as we planned. We had some trouble wiring up a few of the sensors. We originally planned to use many more, around 8, but we were only able to use around I think 3 or 4. So here is a slide for our project budget. Total system cost was actually a little bit under $65. We were unable to use a few of these sensors like the remote control, the PIR sensor, the external pH tester, we are still including in the price. Yeah, and the IR sensor is also not something we could get working. And we used 2 PIC 886F kits, and we did not use the Mega R3 kit in our project, which is just one. For project timelines, we started buying the kit and the supplies and extra peripherals around mid-October. Then we started physical construction early November. We finished pretty late, very much into December. We started testing the system pretty much the week before demo. We were editing the cost pie chart pretty much the whole project length. We were logging the work pretty much the second half of the project. We've been searching for the NP-Lab code, the same much the whole project. We prepared for the demo, and after this week, once we get our kits back in my house, I plan on taking some measurements and recording the data in my house to see how the project actually works and how it will collect data. So in conclusion, the project is just aimed at letting people interact with a embedded system that shows how to collect environmental readings and show how climate change, is pretty much in every environment and around the world. We are, choosing to take the measurements once the semester is over in my house just to test the system and maybe add a few of the other sensors. And so for the next steps and lessons learned, learned it was pretty difficult to implement the C code in NP-Lab because none of us were really that familiar with working in that program, and we haven't ever used a PIC kit before. We also never used a Proteus simulation software, so that was also another learning curve. And physical construction was another learning curve. I've never had to build an embedded system in person before like that. So, and I think that should be it. The last slide is just references in IE format for a project. Is that long enough?